Hey everyone, welcome back to my Unreal Engine 5 Beginner's Guide. This is part 4 in the series where we will dive into Blueprint by creating a simple launcher weapon using Impulse Node. We'll also get a bit destructive in our office level from the previous lessons with our newly implemented weapon system. Let's get started. Now, first thing first, let's create our projectile for the launcher weapon. Instead of placing a sphere in our scene, every time we will create a reusable blueprint class. Let's take an existing sphere object in our level and turn it into a reusable blueprint class. Now, if you don't remember how to quickly add a simple shape into our scene, quickly go to the toolbar on the top of your screen, click on the drop down, go to shape, and drag in a sphere. After you select the sphere in your level, if you go to the right side where the detail panels is, you can see there's a button next to the add button, which will convert this actor into a reusable blueprint class where we can have scripting behavior in the future. So click that button and give it a name such as BP underscore, which stands for blueprint, BP underscore Cannonball, and that should open up your blueprint window right away. If the blueprint window doesn't open for you immediately, you can also go to the content drawer and just double click the BP underscore Cannonball object. And what's most important for our Cannonball, which is the projectile, is going to be the simulate physics. Make sure we check that, and then we can change the static mesh material to maybe something like more metal-y. I'll just choose this one. Yeah, that looks like a Cannonball to me. And we can just hit compile, save, and we can close this window. Now let's quickly talk about blueprint instances. If you're coming from Unity engine, think of blueprint like prefabs. Once you create a blueprint, we can spawn multiple copies in the world without needing to duplicate everything manually. This makes our workflow way more efficient. So, as you can see in our level, we have only one cannonball. And we can obviously hold down Alt key and drag it to the side to create a duplicate. And if you look at the naming convention, they have the similar name, but most importantly, they share the same blueprint class that we have created previously. I can also open up the content drawer and drag in one of the same object as well. So these three Cannonball, they are three different instances, but they are all from the same blueprint class. So at the end of the day, they will have the same blueprint behavior in our game world. Now that we have the Cannonball created, let's handle spawning it into our level blueprint, because we can't just drag in our Cannonball forever. We want to create a Cannonball when we press the spacebar, and we're going to do this in our level blueprint. Go to the toolbar once again, and we can locate the open level blueprint here. So I'm going to right click in our event graph and type in spacebar. And just like that, we're going to select the keyboard event spacebar. I'm going to drag out from the pressed execution pin. I'm going to type in spawn actor from class. And this node is very important node, and you're going to use it multiple times in the future. But just a very easy way to remember it, the class pin, which we will select our BP Cannonball, is going to be in charge of spawning the set class that we have put in there. And the return value is going to return the specific class object that we have spawned, and spawn transform is going to dictate where in the game world we're going to spawn the object at. If you right click on the spawn transform pin and split the structure pin, we can see there's spawn transform location, transform rotation, and scale. So we can have a lot of control on where we want to spawn the blueprint object and how we're going to spawn it. And just for showcasing purposes, I'm going to compile and save, go back to the test level, and I want to see the location for this object. I'm going to right click and copy, go back to the test blueprint window, and I'm going to paste it into the transform location. I'm going to compile and save, go back to the world scene. I'm going to quickly delete these three Cannonball, press play, and if I hit spacebar, it should spawn Cannonball where we specifically set the location at. And And once again, we have the spawn transfer location at this coordinate, and we're spawning the BP Cannonball blueprint, and we're going to execute this node whenever we press the spacebar. Now, obviously, we don't want our cannonball to just drop onto the floor whenever we spawn it. We have to have a little bit of momentum, some kind of impulse force pushing the cannonball towards our target. So that's what we're going to do using the impulse node. So go back to the level blueprint editor, and we're going to continue on from the spawn actor node execution pin. So drag out and type in impulse. And we're going to use add impulse. And as you can see, it immediately initiated another static mesh component, but there's no target for this static mesh component as of yet. And what we want to do is we're going to drag out from the return value from our spawn actor and plug it into the target. So in this way, after we spawn the cannonball actor, we're going to return its reference, gets the static mesh component within the cannonball, and we're going to add an impulse force into the object. And just quickly, what's the difference between force and impulse in Unreal Engine? It's very simple. Force is continuous and applied over time. Think of it like gravity or constant movement towards a direction. On the other hand, impulse is sudden. Instant force applies once, which is perfect for launching projectile, in our case the cannonball. We're just going to give it a huge amount of impulse force right as we press spacebar, and we're going to let the gravity do the rest. Let's quickly go over the impulse node. It's very simple. Again, we have the execution pin coming from the spawn actor. We have the target pin, which is the node to figure out what object in the scene we're going to apply the impulse force to. Of course, we can't forget the most important pin in our node, which is the impulse vector. This vector pin dictates the magnitude and direction of the impulse force we're going to apply to our target object. And just for demonstration purposes, I'm going to type in 1000 on our y-axis and make sure you check the velocity change boolean. By making sure this is checked, we're going to apply the impulse directly to the velocity, ignoring any object mass. If unchecked, the impulse is scaled by mass, meaning heavier object require more force to move. And obviously, for gameplay purposes, we're not going to care about how heavy is our cannonball at the moment. And let me compile, save, go back to the test level scene, and I'm going to change my camera looking at this way. And remember, we added 1000 unit to the y-axis, and the y-axis is this green axis, which is pointing towards that side. So I'm going to hit play, and if we did everything correctly, the moment we press spacebar, we're going to spawn a cannonball and apply an impulse force towards that side of the office. Let's test it out. Spacebar, spacebar, spacebar. And as you can see, in our previous lessons, we have enabled physics to all our objects, all the furniture in the office scene. That's why when the cannonball hits one of the statue, or in fact, it hit all of the statue, it kind of hit them around and off the table. And again, let's go back to the event graph and take a quick look at our blueprint. So again, the moment we press the spacebar, execution goes to the next step, which is the spawn actor. We're going to spawn the cannonball at location here, and then we return the spawn object references, gets its static mesh component, and we're going to add an impulse force towards the y-axis by 1000 units, specifically 1000 velocity unit. In Unreal Engine case, it's going to be meters per second towards that direction. So in our checklist towards the launcher weapon, we have finished the creation of the cannonball object. We also finished the blueprint where we spawn the cannonball and add some kind of impulse force towards the cannonball. But there's a key component that we're missing, which is the aiming aspect. Right now, if we hit spacebar in the game, the cannonball is just going to shoot out of midair. And if you played any first-person shooter, you want to make sure the bullet is coming out of the player actor. not from some random place in our game world. So with that in mind, and also with the game being played, if you hit F8, we will eject out of our player actor, and you can see there's a default pawn object in the outliner. In short, the default pawn object is a physical representation of our player in the game world. So if we go back to the game world by pressing F8, we're flying around in the scene, but what's actually happening is we are controlling the sphere, the default pawn in our game world. If we press escape and get out of the game, the pawn is not there anymore, because by default, Unreal Engine is going to spawn the player actor pawn as soon as the game starts. Remember the event begin play? Similar like that. The most crucial part is we need to know where we're going to spawn or instantiate the cannonball in our game world. So we have to make sure we're reading the proper location of our default pawn, and that's where we're going to plug in that value into the spawn transform location. So let's go back to our level blueprint event graph and right click in an empty space and type in player actor. Actually type in get player pawn, the second option. And here we got a node that is different than the red node on top or the blue node like the spawn actor. All the green node in the Unreal Engine is called a pure node or a pure function, which doesn't have an execution pin. We're going to get into detail of all the different kind of node in our blueprint system, but just for now, just remember, we don't need an execution pin because all we're doing is getting a value, in this case, the player pawn actor. As you can see, the input pin dictates which player controller we're going to reference to. This is important in a multiplayer game, but in our case, we're just gonna stick with index 0. And the return value is going to be the pawn object reference. We're gonna drag it out and type in actor location. Again, we're gonna get the actor location, and this is a pure function once again because we're only getting an information. And here we have the return value, which is a vector, and you can see the color is the same as the spawn transform location. So we're gonna plug those in and hit compile and save. And if we press play, actually I'm gonna go back to this window. If we press play, and every time we press spacebar, it's gonna shoot out from where we are standing. And there's one flaw in this implementation because, as you can see, I'm looking at the left side of the object, but we're still impulsing the cannonball into that direction. Because we are only adding 1000 units of impulse into the y-axis, no matter where we're looking at. Now finally, we're in our final step of creating our ultimate launcher weapon, which is to adding the functionality where we can aim at where we want to shoot our projectile. So we're going to talk about two pure functions very quickly. So go back to your event graph, drag it out from the return value pin, and type in get actor rotation. And one more time, get control rotation. Now you might think, oh, it's very simple to make sure our projectile is rotated properly towards where we're aiming. We just need to do the similar thing where we did on the location, but just on the rotation part. So you will obviously get the get actor rotation and plug that in into the respective pin. But let me quickly tell you why that won't work. Let's go back to our world scene, press play, hit F8, eject out of our default pawn, and select the pawn. And you can see in the details panel, the current rotation is 44 on the Z axis. Let's go back to the control, press F8, and let's do a 180-degree turn. F8 again, and you can see the rotation didn't change at all, although we have turned 180 degree using our camera. For whatever reason, in Unreal Engine, the default pawn rotation doesn't change depending on the camera location. But by using the control rotation, as you can see in this node, we can get the rotation of the controller, often the view rotation of the pawn actor. And that's exactly what we need. So let's delete that node and plug this return value into the spawn transform rotation. Let's hit compile and save, go back to our game world and press play, and we're gonna try out by pressing the spacebar. And you might think, okay, Pixelton, this didn't fix anything. We're still only shooting the projectile towards the y-axis and not where we're aiming at. That's because we're not done with our implementation. Let's go back to the event graph. And now that we have configured or set up the correct rotation to our spawn object, what we need is to apply the impulse force towards that location. So all we did so far is set up the spawn location for our cannonball and the spawn rotation for our cannonball. But we didn't apply the correct or enough force towards the forward direction into our cannonball. So what we're going to do is go to the return value pin and we're going to type in forward vector. More specifically, get actor forward vector. And what this is going to do is it's going to get the forward, which is the x-axis for our return actor, in this case our cannonball, and we're going to apply the impulse force into that axis alone. And the reason we set it up the rotation correctly beforehand so that whenever we're aiming at, it's going to be the forward actor for the projectile. And of course, we can just plug in the return value into the impulse vector and call it a day. But by default, a vector has a value of 1, and 1 velocity change is not going to help us whatsoever. And the idea of vector or 3D mathematics sounds hard, but it's a very simple concept once you get a hand of it. I have planned in the future to teach you about 3D mathematics and game development mathematics. And if you want that, make sure you subscribe and like the video so you don't miss out on any future tutorials. So quickly, we're gonna hold down Alt, click on the return value pin to break the connection. We're gonna drag out the return value and type in multiply. By default, this was trying to multiply it and vector with another vector, but we're just gonna right click and convert the pin into a float. And we're gonna connect the output and convert the float once again. And we're gonna type in 1000 into the multiplication. So just like that, we have set up the correct rotation to our cannonball. We are getting the forward vector for that specific cannonball, applying 1000 units of multiplication, and ultimately adding the impulse force towards that forward vector. Everything is set up correctly. We hit play and press spacebar. We are indeed initiating the proper direction. Now I think this is not fast enough for me, so I'm just gonna go back to the blueprint and maybe change this to 4000. Hit compile, save, and let's see. Yep, the speed looks good to me. And I think the cannonball is not heavy enough, so I'm gonna go to the BP cannonball, open up the blueprint class, and go to the physics section. I'm gonna manually override its weight. Right now it's just 100 kilograms. I'm gonna change it to maybe 500 kilograms. Compile, save that change, close down all the window, and if we press play, and you can see we're doing way more destructive action than we had before. And that's it. We built a simple launcher weapon and learned about blueprint instances and important notes like impulse and spawn. If you found this helpful, drop a like and subscribe for more Unreal Engine 5 tutorial. I will see you in the next part in our series.